Good morning to you all, my dear students. Let's start this session. In this session, we'll be discussing the method of addition of the two vectors when the vectors are given in the form of arrows. The students are aware that the triangle law of vector addition can be used, or sometimes the parallelogram law of vector addition may be used for the purpose of adding the two vectors. But here, sometimes the students have got the ambiguity whether the triangle law of vector addition to be used or the parallelogram law of vector addition to be used. Similarly, while drawing the arrows, what are the conditions imposed on the drawing of the arrows? And what are the permissions given to the students when he is drawing the arrows? These things will be discussed. In addition, if you are interested to write the magnitude of the sum of the two vectors, or if you are interested to write the magnitude of the difference of the two vectors, how do you write the equation? For example, if A and B are the magnitudes of the two vectors, in terms of these magnitudes, you can write as A square plus B square plus 2AB cos theta sometimes, and similarly, A square plus B square minus 2AB cos theta in some other situations. So here, in this session, I'll try to make clarification that under which situation you will be using the positive symbol and under which situation you will be using the negative symbol. Similarly, under which situation the triangle law of vector addition to be used and under which situation the parallelogram law of vector addition to be used. And similarly, while drawing these arrows, what are the conditions to be imposed and what care we have to take? So all these things will be discussed in this session. And if you are well versed with these preliminaries of the vectors, then in almost all chapters where we'll be dealing with the vectors, the mathematical formulation will become very simple if you follow these instructions. I hope you'll be with me. I'm going to share certain videos or certain slides with you. Please be with me. Yes, you are seeing here a figure where vector A and vector B are given, and these vectors are drawn in the form of arrows. The two vectors are making certain angle 60 degrees with respect to one another. Regarding the angle or regarding the direction of the vector, I'd like to mention one thing here, that the angle is always measured between the two vectors when the two vectors are drawn such that their tails are coincident. The tails of the two vectors are touching to the same point. In this situation only, you will draw the angle. For example, here the vector A and vector B, the tails of these two vectors are coincident and some angle between them. For example, here the angle 60 degrees is shown. And the angle is always measured in the anti-clockwise direction. That means you have to start the measurement of the angle from A and you have to go towards B. In this direction, if you follow, the angle will increase in the anti-clockwise direction. Here, I'd like to mention another thing, that when the arrows are used to represent any vector, the arrows may be shifted anywhere on the screen. This permission is accorded to you, but here certain conditions are also imposed. For example, you can shift the arrow to anywhere, any location on the screen, but you're not permitted to alter the length of the arrow. You're not permitted to tilt the direction of the arrow. Now, Under this situation, let us make how we can change the location of the vector B. Let's see. This is the vector B. As it is permitted, I'll take here the copy. This is vector B. I'm taking a copy here. Yes, this is vector B. I'll take a copy here. Then let me take here like this. This is vector B. This vector B can be shifted anywhere on the screen. See, this is permitted. I'm changing the location of this vector B. So you can change the vector B anywhere as you wish. See? This is possible. Let me take here. I'm taking a copy. This I have copied. I'll take, see, this is vector B. Now, you are noticing here that vector B and its copy, both of them are vector B, and there is no discrepation between them. Both of them are parallel. They are pointing in the same direction, and they are having the equal length. Therefore, there is no difference between them. Now, according to the quartet permission, you can shift this vector here. Now, if I take the vector here, now you see here on the head of vector A, the tail of vector B is coming. So while drawing the two vectors, two things are possible. Number one, the tails of two vectors are coincident. This is possible. Number two, on the head of one vector, the tail of another vector can be drawn. So these two situations are possible. Now, again, I'll take the copy of vector A. See, this is, I'm taking, this is vector A. I have copied it. I've taken its copy and I'm pasting here. See, this is vector A. Of course, the vector B is like this. This is vector B. Now, if you want to add these two vectors, A and B, the summation will come something like this. This is green colored arrow you are seeing here. This indicates the sum of vector A and B. Now, in the figure, it is clear. I'll just enlarge this figure. You're seeing here. Here, this is a parallelogram. This parallelogram is comprising of two triangles. One triangle is above the green colored arrow and another triangle is below the green colored arrow. The triangle which is above the green colored arrow, that is comprising of vector B and A. Vector B and A when added, you are getting the resultant vector as the green colored arrow. The green colored arrow is giving you the summation of the two vectors. And this summation of the two vectors is obtained by the triangle which is appearing at the above of the green colored arrow. Similarly, below the green colored arrow, there is one more triangle where vector A and B are added. So this green color arrow is giving you the summation a plus b and as well b plus a. So in order to add the two vectors, you can draw the triangle. So that is the triangle law of vector addition. And in the triangle law of vector addition, you have to draw the two vectors such that on the head of one arrow, the tail of another arrow should come. So this is the situation. So my dear students, you have to remember this fact that the triangle law of vector addition is useful when on the head of one arrow, the tail of another arrow is coming. Now, if you see this parallelogram, the parallelogram is drawn when the two sides of the parallelogram are represented by the two vectors. We have started this figure with the two vectors A and B, and those vectors are having their tails coincident. When the two vectors are drawn such that their tails are coincident, then you can construct one parallelogram. So parallelogram law of vector addition is used when the two vectors are drawn such that their tails are coincident. And the diagonal which is drawn between the two vectors indicate the sum of the two vectors. The addition of the two vectors is obtained by drawing one parallelogram where the diagonal of the parallelogram passing in between these two vectors indicate the sum of the two vectors. Now, in order to take the difference of the two vectors, just very simple, you will just add one vector and inverted rotation of another vector. For example, if you want to find a minus b, then you will add vector a with negative of vector b. So in order to take the negative of the vector b, you have to take just a vector b in inverted direction. So we'll be seeing in the next slide. Okay, my dear students, you're seeing here a figure where the difference of the two vectors are shown. Vector b minus vector a. Vector a is being subtracted from vector b. So here, the difference of the two vectors is shown by another diagonal in the parallelogram. If you draw one parallelogram, in any parallelogram, two diagonals are possible. You are seeing the two diagonals. One diagonal is that which is passing in between the two vectors a and b. Here in this figure, vector a and vector b are shown in black color. And in between these two vectors, a green color diagonal is passing. And this green color diagonal is showing that sum of the two vectors, that is a plus b. Similarly, there is another diagonal which is drawn in red color. And this another diagonal is showing the difference of the two vectors, b minus a. Of course, you can also find the vector a minus b, and that will be in the inverted direction compared to the direction which you are seeing in the red color arrow. So, in conclusion, you can remember that every parallelogram has got the two diagonals. And when the two sides of the diagonals are representing the two given vectors, for example, a and b, such that their tails are coincident, in that case, the diagonal which is passing in between the two vectors a and b, that indicates the sum of the two vectors. And another diagonal which is connecting to the two heads of the given vectors, that indicates the difference of the given vectors. So all these things are included into the triangle law of vector addition and parallelogram law of vector addition. Moreover, In order to find the difference of the vector, one vector you have taken as it is, and another vector you have taken in inverted direction. When vector is inverted its direction, that indicates the negative vector. And the addition of positive vector and negative vector together will give you the difference of the two vectors. Okay, my dear students, here inversion of the vector, that means if you want to reverse the vector, there are the two possibilities. One possibility is that you have to just inverse the direction, or another possibility is to obtain or to make the magnitude in the reverse direction. If you want to write the magnitude in reverse direction, the particular vector is treated as in negative direction. And moreover, if you want to invert the direction of the vector, or if you want to invert the arrow, simply the angle to be changed through 180 degrees. Now, let us see how the magnitude of the resultant vector can be found. The magnitude of the resultant vector is found with the equation, as you are seeing here, a square plus b square plus 2ab cos theta whole taken root. So this indicates the magnitude of the sum of the two vectors. Now, in order to find the magnitude of the difference of the vector, you have to make one vector in reverse direction. Either b or a, you have to invert. Now, the inversion of the vector is equivalent to assign a symbol negative. For example, here the vector a has to be assigned as negative symbol. So you will get b minus a. Now in the above equation, wherever you are finding a, you just replace a by minus a. So the first term is a square, but you take the negative of a square, again it is positive. So there is no change. Again you write a square plus b square as it is. Next, 2ab cos theta, where instead of a you write minus a. So 2ab cos theta, in that if the value of a is inverted, then you'll get minus 2ab cos theta, as you are seeing in the third place. So b minus a can be written as, the magnitude of vector b minus a can be written as you are seeing here, the third equation, a square plus b square minus 2ab cos theta. This negative symbol is arising because the polarity of the vector a is changed from plus to minus. So out of the three terms, the first term a square is not changing its symbol, because when you square any vector, or if you square any quantity, let it be positive or let it be negative. In either the case, you'll get the positive symbol. Therefore, you got the first term as a square. Next is b square. And the third quantity you have got negative because the symbol of a is changed from plus to minus. Therefore, you got the third place as minus 2ab cos theta. So in this way, you can write the magnitude of the difference of the two vectors. There is another analogy. When the vector a is reversed, you can say that its magnitude remains unchanged, but the direction is inverted. The inversion of the direction is nothing but the changing its angle through 180 degrees. Therefore, the value of angle theta is increased with pi radians. And you know, cos of pi plus theta is minus cos theta. So for that reason also, the third quantity is coming to be minus 2ab cos theta. Therefore, the magnitude of the difference of the two vectors is written as a square plus b square minus 2ab cos theta. Now here, if you come to the figure, in this figure, this is a parallelogram where one diagonal which is passing in between the two vectors a and b is indicating the sum of the two vectors. And whereas another diagonal, which is joining to the heads of the two vectors, which is shown by red colored arrow, that indicates the difference of the two vectors. Hence, in this way, you can write the magnitude of the sum and the magnitude of the difference of the two vectors. Now let's see another slide. In this figure, you are seeing a polygon when several number of vectors are given such that these vectors are able to be drawn by joining to one another such that you got one closed figure. In this case, there is possible that we can write a mathematical equation by using these vectors. Four vectors are given here, A, B, C, and D. My dear students, here, if you see the direction of the vectors, vector A is moving in the clockwise direction, vector B is in anti-clockwise direction, whereas C is again in clockwise direction and D is also in the clockwise direction. So all the vectors are not moving in forward directions. Some vectors are moving in reverse direction also. But completely they are making one closed figure like a polygon. In this case, you can write them into one equation. And you know, every equation contains some right-hand side part and some left-hand side part. At one side of the equation, you will take all those vectors which are moving in one direction. And on the other part of the equation, you will write the vectors of opposite direction. Now, if you see here in this figure, vector C, vector D, vector A, these three are moving in the clockwise direction. Again, I'm repeating, vector C, vector D, vector A. These three are moving in the clockwise direction, and vector B alone is moving in the anti-clockwise direction. Therefore, you can write the equation where on one side of the equation, only B will be there. And on the other side of the equation, three other vectors, that is A, C, and D will be there. In this way, you can write the equation. See here, this is the equation you can write. Vector B is equal to vector A plus vector C plus D. And same equation can again be rechanged like this. Let me write here. This way you can write the equation. Vector B alone is at one side. The same equation can also be written like this. Vector A minus vector B plus C plus D all together are making zero answer. Here, you can note here that all the vectors are positive except vector B. B alone is negative because B alone is moving in the opposite direction. That B alone you have taken in a negative direction. So here, the method is like this. You have to arrange all the vectors on one side of the equation which are moving in one particular direction, and all other vectors which are moving in opposite direction, you have to take on other side of the equation. Likewise, you will write the equation. Or if you want to write all the vectors at one side of the equation and at other side of the equation, if you want to write zero, you have to use some vectors with positive polarity and some vectors you have to use with negative polarity. So the positive polarity to those vectors which are in one direction and negative polarity to those vectors which are moving in opposite direction. In this way, you can write the equation when the vectors, and remember, this particular procedure is only applicable when the vectors are giving you the closed figure making one polygon. However, the number of vectors may be 4 or maybe 5, maybe 6, or any number, or 3, irrespective of the number of the vectors, you can use this procedure. Now, using this procedure, let's see what will happen. Let me delete all these things. You consider there is a vector like this. This is one vector. And let me write its name as okay. Let me write its name as A. This is vector A. I'll draw here some other vector. See, this is one vector. Then I'll draw another vector. Right? Now, if you see the direction of the vector, the direction of the red color vector is like this, and the direction of green color vector is like this. According to the triangle law of vector addition, you can write the mathematical equation. Let me write the names of these vectors. Okay. Let me write the name of this vector. A, and some subscript will be there. Of course, subscript is X. Let me take the green color. And let me take another vector. This I'll take in red color. And this is not X, is Y. Okay, let me copy here. This is vector Y subscript A, and this is another vector Y subscript X. And let me write here this. Now, the names of the 3 vectors are available here like this. Vector A in black color, vector A subscript X, which is in green color, vector A subscript Y, which is in red color. Now, you implement here the triangle law of vector addition, and using that law, tell me what is the mathematical equation governing these 3 vectors. You can write the mathematical equation using these 3 vectors. See here, 3 vectors are there. One vector in black color, that is in diagonal direction, and other 2 vectors. One is AX in horizontal direction, another is AY in vertical direction. Using these 3 vectors and using the triangle law of vector addition, what mathematical equation you can write? the green vector and the red color vector are moving in anti-clockwise direction, and only black color vector is moving in the clockwise direction. That means the mathematical equation is written where the black color vector will come to the one side of equation, and other two, the green and the red, will come to the other side of the equation. The equation will become something like this. Okay. The equation will become something like this. This is the equation. Let me write that equation here in the figure. Now, according to the triangle law of vector addition, you can write the mathematical equation like this, where vector A is equal to vector AX plus vector AY. See, blindly we cannot write any equation. This equation is being written according to the principle of law of addition of the vectors using triangle. So this equation says that vector A, or any vector which is in diagonal direction, may be splitted into the two parts, and here the two parts are perpendicular to one another. So one part is called the component, because the component, green colored component, is in horizontal direction, that you say as the horizontal component. Similarly, the red color vector is called as the vertical component. So any diagonal vector can be divided into two parts. One is the horizontal component and other is the vertical component, or one is the x component and other is the y component. Remember that when you add different components of the vector together, all the components together will give you the total resultant vector. So any total vector can be splitted into various components, and the terminology of the components are sometimes as the x and y components, sometimes horizontal and vertical components, and similarly sometimes radial and tangential component. And remember, in all these terminologies, various components will be held perpendicular to one another. For example, the horizontal and vertical components will be perpendicular to one another, and if you add them, the total will give you the actual vector. Similarly, the x and y components of the vector will be perpendicular to one another, and if you add them, the total will be the given vector. In the same way, when the tangential component and radial components are considered, these two will be again perpendicular to one another, and the sum of those two components will give you the actual vector. Now let's see how is this possible. Let me take another figure. Let me remove this. Okay. Let's consider one circle. Okay. Here, let's consider one straight line. Let's consider one simple pendulum which is suspended here. Okay. And this pendulum is taken here. Right. This is the bob of the pendulum. Bob the pendulum will go to a different location. And let me remove this remaining part of the figure. Okay, this is a simple pendulum. And let me draw one vector, that is the gravitational force vector. The gravitational force will be always act in the downwards direction. Let me draw one vector. I'm drawing here the brown color arrow indicating the gravitational force. Okay. Gravitational force is acting in the downwards direction. Always it acts in the downwards direction. And now I want to split this gravitational force vector into two components. One I'll take along the direction of radius. See here, this red color vector is continuing in along the direction of the radius. Therefore, I will call this as the radial component. In addition to that, I'll take another vector in this direction. See, first let me declare here this green color line is acting as a tangent to the circle. Okay. You are seeing here green color vector. Again, I'll take a copy of that green color vector here. And I'll take the copy of this red color vector again here. As you know, vectors may be shifted anywhere on the screen. So here you are getting two triangles. One triangle is the left side of the gravitational force vector. Other triangle is the right side of the gravitational force vector. Now, taking any triangle, you can write the equation like this. This is green color. This is green color vector. This is tangential vector. And this is radial vector. This is force. This is force. This is force. Let me take this equation and write there. See here, this force is acting in the downwards direction. I'll write here. This is gravitational force acting in the downwards direction. And next, this is radial component of the force. Radial component of the force, which is shown in red color. And this is tangential component of the force, which is shown in yellow color. Now, I have shown you the names of these vectors. You concentrate here three vectors. One is the black color, which is the gravitational force acting in the downwards direction, and other green and red, which are the components of the vector. Okay, you see here the figure. In this figure, you concentrate on the gravitational force which is acting on the bob in vertically downwards direction. That is the gravitational force. And this gravitational force vector is splitted or divided into two parts. Those two parts are shown by the green colored arrow and red color arrow. These green color and red color arrows are perpendicular to one another. So these two vectors are called components. Of course, they are component. And according to the figure, if you add the green color vector with red color vector, the sum is going to give you the resultant force, that is the gravitational force. So gravitational force is being divided into the two parts. And these two parts are called the radial component and the tangential component. Tangential component being along that tangent of the circle, and radial component is along the radius of the circle. Now here, in the simple pendulum, the purpose of the radial component is produce the tension in the thread, and the purpose of the tangential component is to produce the acceleration in the body. So the simple pendulum experiences the acceleration into it, and this acceleration will be proportional to the angle of displacement, and in this way you will be equation for the simple pendulum. Now here, these are the different types of applications of the vectors. So in every such application, the students are required to use the triangle law of vector addition, the parallelogram law of vector addition, and the preliminaries of these vectors. So I hope this session is helpful to you, and by this I'm going to close this, and I wish that the concept of the vectors become very much clear to you. If still any doubts or clarity is any doubt is persisting, or any type of clarification is required, our next session will be there, and I suppose that the comments should be given by you, so that I'll make more improvements into the further sessions. So goodbye.